last little game of today, or not game, but topic, issue, point is we should, even maybe more so than earlier, think about all the assumptions we've made for doing the stuff we've done. And of course, before actually believing in all our results, we should think about whether our assumptions appear okay. Luckily, it is done very much like you've seen before, at least as a first step. We tell you that you should go check normality assumption of the residuals, of the deviations from the line, and the QQ plot or the Wally plot you can use for that, right? So it's same story as you know, QQ plot or Wally. You can use Wally. And we can then check. That's an additional thing that's new for today, actually. We can check by plotting residuals as a function of the fitted values. So we're going to, let me check here. Did I bring one, or should I just play with these ones? Here we are. Of course, I brought one. What do you think, you guy? Of course, I brought it. Here we are. Or Wally plot. There we are. I don't do Wally today. You can play with Wally yourself. But here we are. I do QQ norm on the residuals. And let's just dwell on the details here. I put my results into an object that I myself name the fit. That's how well the line fits to the data. So I'm fitting my model to the data. That's the terminology. That's why we use such a name. You can call it what you want, and you have a very good fantasy in making names. So feel free to use such nice names in your programming also to make it a little more fun. Then I am looking at when I have saved my results in an R object called fit, which is a linear model object. There's all sorts of nice information saved for me to go on with and look at after that. For instance, already the residuals have been saved in an object named residuals within the fit object. So fit $residuals simply is a vector of my residuals of my data. And I can then do a QQ norm plot on the residuals, or I could do Wally. You can go check my R code and see how to do Wally just like we did before. Or, that's a new thing now. Also, funny enough, there is an object within R. So that's an R object that is named like that by the R people that implemented this. That object is called the fitted. So these are the fitted values of my fit. The fitted values are the values on the line for the x's, which is in my data, right? So that's y I hat. The fitted values are y I hats. So I plot the residuals versus, like this, right? Hats, comma, residuals. I plot residuals versus fitted. That's the new plot now in a regression context compared to what you've seen previously. Here I'm looking for structure because I have assumed a linear model, right? Which means I assume that the line is okay. Of course, I should always think about whether the line seems like an adequate description of my phenomenon. Could there be a curve in place instead? Of course, I would look for that already in my initial data plot. But if there were a curve, that should be more clear here, actually. And also, I'm looking at whether there seems to be a stable level of variability across my x values, right? I look for whether my assumption of variance, homogeneity, homoscedasticity for an econometrician, whether that seems okay or not. The classical deviation from such a plot from what you would like to see. This is fine. Whoa, nice, I'm happy. It's flat like this, right? Now, had it looked like this is a trumpet. It is. Or at least it's a trumpet shape. That's the classical deviation that we often see in many real-life phenomena, biological, economics phenomenon. Because if I have data with small variabilities for small numbers, small x's, right, and large variability for large x's, that often happens if I have a positive relation to the y's also. That would mean that my assumption of the same sigma across the whole space would not be okay. So this is a visual investigation of my assumption of sigma being the same over all the X space. That is a non-trivial assumption that we need to check. It's not always true. Very often it's not. In this case, it looks nicely, like that. That's nicely flat. If we're in doubt about how bad it could be, we can do Wally plot-like thing. Actually, Wally plot allows for residual plotting also, not only normal plotting, but hey, I didn't show you that. But Wally plot can also do repeated plots like that to see whether it looks weird or not. Anyway, that's residual plotting. I did the whole stats for regression now. Next time we'll do an important step. We will move on to having more than one X. Life consists of more than just single XY relations. So that's all for now. Enjoy it and see you next week.